welcome back. This is the second video of the series, and here we're gonna learn the introduction to machine learning, artificial intelligence, deep learning, and data science. Also, we're gonna learn about type of machine learning and linear regression, some maths around machine learning. So this video will be more focused towards machine learning, as machine learning is a part of artificial intelligence. We have to learn that to become a good AI developer. So let's start from the basics. So have you seen these cars like called Wemo around Italy? They are working very fine. Let me show you. So Wemo is also known as the Google's self-driving car, and it's headquartered in California. So if you live in California, you have seen these Wemo cars. These are the self-driving cars. You just book them, come to you, and you can sit there. There's no human interaction. You just sit on this, and you reach your location. So how this all is working? Behind it there are sensors and computer vision, but the deep technology within it is machine learning, as machine is learning in what environment it is currently and how it perceives that environment and how it behaves. We have this AlphaGo model from Google. As you can see, this is a robot from Boston Dynamics. Boston Dynamics is making very good robots. Like this is a humanoid robot. It behaves like human, works like human, and so it is learning the human behavior, right? And the machine is learning itself by doing the iterative task again and again. So this is how we gonna learn our machine learning. So let's talk about it again. AI versus ML versus DL versus DS. So AI is artificial intelligence, ML is machine learning, DL is deep learning, and DS is data science. Universe is AI. Let's say we have a huge ball called AI. It is a process in which the application able to perform its task without human intervention, right? So we have Netflix recommendation system, Amazon's recommendation system for frequently bought items, and also you might like those items also. And we have AI engines for game playing robots and many other use cases like business driven goals, self-driving cars like Tesla we have, and Boston Dynamics robot. Also, at the end of the day, we have to become an AI engineer. So this is all in AI. But now you might be thinking, Harivansh, you told us AI before, this is the field that machine learning is a part of. So what is machine learning? So it is a subset of artificial intelligence which provide the statistical tools to analyze the data, visualize the data for prediction and forecasting. So we can make predictions based on the previous data. Like if you have seen uh, if there will be rain, it will be colder on the next day if it's the month of December. So that's an analysis done based on the previous data. Like I have seen so many winters, and now I can say that yeah, this is how the things work. So that's how machine learns. Machine learns through experience, through data, through larger data sets. So you might be thinking, what is deep learning? Uh, the deep learning is more like we are trying to mimic the human brain. Let me show you an example. If we open the graph view, you can see these nodes. These all are interconnected nodes because these all are tags and these all are nodes. If I go to Apache Spark, it will open the nodes for the Apache Spark right here. Okay, and these all are connected with it. Like database is connected, as you can see. Python is connected, machine learning is not connected with Apache Spark right now, but we will work on it. So deep learning is trying to mimic the human brain. For this we use multi-layered neural networks. I have shown you this is the single layer neural network, and for this we use multi-layer neural network. Because of deep learning we are able to solve very complex situations. Like if we go to Edge and search what we can solve through deep learning. Okay, and go to the search button. It will do a thorough search around, and it says for computer vision, deep learning access in tasks involving images and videos, image classification, object detection, image segmentation, facial recognition and biometrics, natural language processing, text classification, and machine translation. There are so many, so many use cases like game AI, content creation. We can also use for creating realistic images, videos, and virtual environments. So this is how we use. This is what we use deep learning, and you. This is the data science. This is a new field you might be hearing right now. So let's say we have a large amount of data. Okay, this is the big data. We have a large amount of data and it is unstructured data. We have it in cloud base and code engineering, pattern system, filter, frameworks, variety, user behavior. We collect data like that, like crazy. If we talk about what data Instagram collects, so you might be thinking like what data Instagram might collect from users. Okay, so there is a lot of things that Instagram collects from the users. I'll say mainly everything. Instagram collect a wide range of data from the user, including personal behavior, device, location, which is used for personalization, advertising, and security and analysis purpose. Types of data collect: personal data and collected data, all content you post, interactions like share, behavior. Instagram monitor your engagement patterns, like how which post you like, follow, comment, save, search, query, add, click, everything it collects. So at the end of the day we have a lot amount of data, and to solve and to find the meaningful pattern from the data, we have this field called data science. And for data science we use all of them, because for pictorial data we use deep learning, for textual data we use machine learning, and it is all part of artificial intelligence. So that's how data science is used. So let's talk about machine learning again. So it is a field of study that gives computer capability to learn without being explicitly programmed. So what is explicitly programmed? Explicitly programmed means you are doing programming, you are using if else loop. You are telling computer, if this thing happens then do this, if this thing happens do this. But machine learning doesn't work like that. It finds pattern by its own through algorithms. So in traditional programming we do explicit program. We give data and program and then find the output. But for machine learnings we get the program. Isn't it amazing? Like we are giving the input data and the output also, and we are getting a program which is a generalized program that will solve each and every problem related to that data, that type of data. So these are the key components of machine learning we need to know. Data. Data is the foundation of any machine learning model. The quality and quantity of data directly affect its performance. Like let's say we have a large amount of data of a coffee shop selling coffee, like which type of coffee it is, and what is the price of coffee, what is the average price. We have to have all of that data, and on that data we will work on. But if we have outliers on that data, the quality of the data is not that good, then it will be a problematic thing, because that data is not going to be used very well. Features. Features are the attributes or the input variables used to make predictions. So these are the input variables and these we can say this is our attribute. Okay, and for making prediction is a program. This is our ML model, let's say, and we are giving see, this is the test data, this is the training data, and if we give any test data to it, it will return an output, and that is our prediction model. The model is a mathematical structure that learns from the data. I'll tell you about it in the later part of this video. Training, the process of feeding data to the model to make it learn patterns. I have already told you about it. Testing, evaluating the model's performance on unseen data. And evaluation, a metric like accuracy, precision, recall, and F1 scores are you are used to access the performance. So type of machine learnings. So there are mainly four type of learnings we have. First one is supervised learning, second one is unsupervised, third one is semi-supervised, and fourth one is reinforcement learning. So in supervised learning, we have data which is labeled data, and machine learns from the labeled data. So we have input and output both. So if we take an example, if we try to predict house prices, firstly we need to know the data which has houses, their specification, and their prices, and according to that we create a model that will tell us what will be the price of for a certain specification of a house. Unsupervised learning identify hidden patterns in labeled data, unlabeled data. Example, customer segmentation. In semi-supervised learning, we have a mix of labeled data and unlabeled data. In reinforcement learning, the models learn by trial and error to maximize the reward, like self-driving cars, games, etc. Machine learning and deep learning, I have told you that we have supervised ML, unsupervised ML. Okay, in supervised ML, we do regression and then classification. We do regression and classification, and in unsupervised we do clustering. This is also can be dimensionality reduction. So let's talk about how we gonna make a workflow of artificial intelligence using the machine learning. Firstly, we collect the data. Data collection is the most important task of it. Data collection, let's go to images. So data collection is a process so that we can get some data cleaning, and after that feature selection, model selection, training, evaluation, deployment, monitoring, and maintenance. And this is an iterative process. Like after the last step, we go back to the first step and do this process again. This is the automated pipeline, like the data collection up on a CSV file, pre-processing using the cleaning brush, training brain lifting weights, and evaluation with accuracy meters, and deployment is like a rocket launch. Yeah. Applications of machine learning: spam detection, image and speech recognition, healthcare diagnosis, fraud detection, recommendation system, Netflix, YouTube, etc. We also have predictive maintenance. This is for the supervised learning. We have age and weight, all like this is our age, then this is our weight, this is our age, then this is our weight. So we have labeled data, right? Now we have to create a model whether we take a new age and it will give us weight. This model is also called as hypothesis. Independent feature is equals to age and the dependent feature is equals to weight. So we have weight which is dependent upon age. As weight depends upon age, there will be only one dependent feature.
Let's keep this video short. We will talk about all the classification problems and all of this stuff in the later videos. Till then, follow the series and you will get to understand all of these. I'll provide the notes in the description down below. So hit the like button, that will motivate me. And if you want, you can subscribe to the channel. It's not mandatory. Till then, bye bye.